Good morning, everyone. Welcome to today's webinar on 3D Studio Max, first one of the year from us here at the NTI Group M&E team. We are just a few house rules before we start off. Obviously, everyone listening is muted. If anyone's got any questions as we go through, the Q&A panel will be open. We'll monitor those and then answer any questions that we can live at the end as well. We are being recorded and a request to fill out the survey after the webinar. There's an additional incentive to fill that out, but I'll go through that in a second. So a little bit about me. I'm here in the UK, been part of the NTI group now for nearly 3 years. And my background has been in the media and entertainment industry, working with Autodesk and 3D Studio Max in particular since its inception. Fun fact, 3D Studio Max turns 30 next month, so that gives you an idea of how old I might, how old I am. But more on to what we're talking about. So we're going to be doing 3ds Max, from Inventor webinar, and that incentive I mentioned for filling out your survey, what we're offering for anyone attending is the chance to win a hands-on online training session with JP. Some details there. Just fill out the survey at the end, and you will be you'll be entered into the draw. With that said, I don't want to take up too much of JP's time. JP's been a friend of mine for 15 years, and now a friend of NTI as well, and got lots to talk about. So let me pass on to JP.
Thank you very much, Lee. Yeah, lots to talk about. That's gonna be the challenge again, the clock, the timing. But let's see how it goes. So my name is Jean-Pierre, or GP. I'm an Autodesk certified instructor. I'm using 3ds Max for over 3 decades now, so a very long time. And I mainly do presentations, training on 3ds Max, but also on Gen AI, agentic AI, when it comes down to NVIDIA's technology and operational digital twins. Before we dive into the presentation, I'm gonna talk about Max, obviously. I'm gonna do some live demos. We have a poll question for you guys, so if you please can answer the poll before we continue the presentation. That's gonna give me some good insights. How are you currently visualizing your Inventor design? So if you can please answer the question, and then we will show you the results before I continue. All right. So I guess everyone answered the question, so we can straight dive into the content. There is the answers of the poll. I see a lot of Inventor Studio, challenging. Inventor Viewport, that provides GPU rendering. That's a huge difference between Inventor Viewport rendering and Inventor Studio. I see some people using Max and some other softwares as well. So thanks for answering the poll question. So let us dive into the content. So this is where I'm going to talk about. I'm going to start really easy, just talking a bit about 3ds Max projects. It's not something new. It's the same what you do in Inventor. You start with a project. Then we're going to discuss how to literally import your Inventor data, some best practices, workflows, real-time rendering. That's one of the topics. So literally having a real-time viewport, high-quality viewport. I'm gonna explain to you how to set it up. We're gonna obviously talk about materials. There are so many different materials, but I'm gonna just point you out what is the perfect material to use and how to set it up. We're going to briefly talk about animation because that's quite unique in 3ds Max, that you can animate or simulate anything. And then we close a bit on the Arnold rendering, which is CPU or GPU render engine available inside 3ds Max. First things first. Oh, and by the way, if you have any questions, please use the Q&A panel. At the end, we do have some room for answering your urgent questions. So first thing you do when you start 3ds Max is to check which 3ds Max project is active. Same as in Inventor, we always work in a project because we want to manage our data. And maybe you want to scale up your project. You may want to invite some additional team members. And let me dive straight into Max. I'm just going to switch to 3ds Max. I already have it open on the background. And this is literally the project toolbar. Normally it's located at the upper right of your screen, but since I'm working on my laptop due to resolution, my project's toolbar doesn't fit completely. So I repositioned this one just below the main toolbar. So this one is very important. So this is literally telling me where is all my Max data going to. So as you can see, I'm working on my local drive. I've created a 3ds Max Inventor folder on my desktop, and that's my default project. Okay, so again, first thing what I do when I start 3ds Max, I check what is the current project folder. If the project is being right, I continue my work. If it's not, I might need to change the active project. So we have an option down here where I can literally browse to another project. There's also a drop-down list where I'm able to switch between previous projects, so some kind of history list. And if I want to create a complete new project, I'm utilizing this option. There's a difference between create a new project, which only creates a single folder, and this one, which is the create default project. And what will happen when you click on create default project, the only thing you need to do is just browse to a folder. Can be local drive, can be network drive, that doesn't matter. The only thing what you need to do is just select a folder or create a new folder, and 3ds Max will automatically create this particular subset of folders. And every folder does have a purpose. Like if we archive the 3ds Max scene, you can compare the archive with the pack and go in Inventor. So in Inventor, if you want to archive your assemblies, you utilize the pack and go. Similar approach in Max, but we call it an archive, and the result, the zipped archived file, will be stored in the archive folders. There's also an auto backup, so Max will create an auto backup file. We have an export, we have import folder available where I placed on some Inventor content already. Previews for animation previews, the renders, etc., etc. Sim cache for if we cache a fluid liquid simulation like oil or water flowing through the machines, we can simulate that by utilizing 3ds Max liquids, and the cache is being stored in the sim cache. So this is literally step number one. Check the current project or create a new project. The second one, and that's just a one-time setup, is check the units, because in Inventor, most of the users, like European-based companies, they work in millimeters, in mil, although there are some rare exceptions where American-based companies work in inches, of course. So that's just one time of a setup that we do the units. If you don't know where to find the units, 3ds Max does have a very handy tool, and it's officially called search 3ds Max commands. And the shortcut key is the X key. So if I just type the X key, I do get of some kind of, call it dynamic input. If you used AutoCAD before, so I can just start typing any command and it will automatically start filtering out every 3ds Max command being available. So this is what I want. I want to check my unit setup. Okay. On the other hand, if you go to the customize menu in the menu bar, you also have access to the custom unit setup. So in this particular scenario, we're going to work in metric. So I'm going to set the display to mil in metric, and the most important one is the system unit setup. And by default, due to Autodesk being an American-based company, the default is set to inches, but that's not what we always want. We want to set this one to mil as well. And 3ds Max will remember this setting. So it's stored in the application itself. So if I restart 3ds Max, I'm still working in mil. So the only thing you need to keep looking at when you start 3ds Max is literally which project is active. And if we accidentally open a file with different system units, you do get a warning, and we will see that warning during the webinar, during the presentation. So this is step number 1. Very important, very important. The second step, I'm going back to my presentation. So step number 1, we talked about that. Step number 2 is how to get our Inventor or Fusion data imported inside 3ds Max, where we do have a choice between quality versus performance. Okay. Also, very important to realize that 3ds Max is capable of importing native Inventor data. So part files and assembly files can be imported as native data, which gives me some huge advantages or benefits, like the part name will be completely respected. It will import all the Inventor appearances. So the materials, so not the physical materials in Inventor, that's something else, but the appearances will be imported. The downside, and I'm always completely honest, the downside, if you have a very large assembly, and what I mean by very large is an assembly consisting out of 10,000 parts, and it might be that the 10,000 parts consist of many fasteners, okay? And 3ds Max needs to analyze the data, so that can take up, if I do have 12,000 parts, that can take up to 1 hour import time. So the question is, do you want to wait for that? Or are you in a hurry? And then the alternative is just to import a step file. Downsides, when you import a step file, you don't get the Autodesk appearances imported, and the naming convention in the assembly is being converted to solid 1, and the next one is also solid 1. So good thing, it's fast. So compared to the 12,000 parts assembly, importing from 1 hour time goes back to 40-50 seconds by step. So it completely depends on how much you're in a hurry. And also it's true for both. If I import native Inventor data or step files, it will respect assembly and sub-assemblies, and we need to open them. Okay, and if you want to continue working with the Autodesk Inventor appearances. So the materials, the render materials, you need to convert them by utilizing the scene converter, and that will automatically convert the appearances to 3ds Max physical materials. On the other hand, the quality of the materials in Inventor, it's not so good. So I strongly recommend to replace the Inventor appearance materials to real 3ds Max materials. And I will dive into that so that you immediately get a good understanding what is the difference. And that's it. Yeah, it's an amazing difference when it comes down to quality. Okay. Back to 3ds Max, So we have set the project. So what I need to do, obviously, go to the file menu in the menu bar, go to import, and choose the import command. Also, if you don't know where to find it, just type the X, start typing import, and 3ds Max will find the import command. So the import itself, it's based on the Autodesk translation framework, so the ATF, the same framework which is being built in Inventor and Fusion. Although it also provides a tremendous amount of additional file formats, because maybe you have a marketing department which is using Adobe Illustrator and creating SVG files, so that can be imported as well. SVGs, I can import SketchUp files if I want to. I can import, all different file formats. So it's a very long list, and by default, it's set to all formats. And the only thing what you need to do is just select a part or an assembly. So this is a small one. Takes up to 3 minutes. We're not going to wait for that. I also imported the file up front, but I'm just going to show you and explaining you what options do we have if we start importing Inventor. This will start on the background, the Inventor server. 10 years ago, when you wanted to be able to import Inventor data inside 3ds Max, you always need to have access to an Inventor license, and that has been changed. So the Inventor server is running on the background, and as soon as you start the import process, it will launch the Inventor server, and it will show you how would you like to import the Inventor file. And this is a very important decision. So imagine you are a product designer and you have a 3D object with lots of curvature, and you want to respect the curvature. So you don't want to necessarily convert it to triangles and lose some curvature. Body objects is going to be your preferred choice, because this is going to respect for 100% the curvature. It takes a bit longer though, but the quality is really high when it comes down to curvature. Literally on the background, your Inventor objects are being converted into NURBS objects. And for the people who are in the industry for a long time, no NURBS are being used in the past if you really want to have some complex surfaces, very smooth complex surfaces. So that's what we call body objects, okay? The other option is meshes. So you do get a mesh. The good thing is, meshes is a bit faster to import, and you do get access to the mesh resolution. You maybe want to later export your 3ds Max scene to a real-time engine like Unity or Unreal, and you want to start decimating your CAD models. And that's possible when you go to meshes, because we do have access to the mesh resolution slider. For now, I'm going to leave it what it is, body objects. We have some basic options, important options. So for the assembly, I want to have references for duplicate parts. So like having instances that they only have one object in the memory loaded in the database, and the rest of the same parts are references. Max will create layers based on materials. So if you do spend some time on materials, 3ds Max will create a layer structure, which is helping me to select objects based on materials. So I can literally later on double click on the layer, maybe called copper, and it will select all the objects in the assembly with the copper material. We have some basic options, and I'm gonna repeat that because it matters. Basic options for importing driving animation. So what's that? If you have a drive constraint or joint, so not both, it's either constraint or joint, in the root assembly, and that's the point, it will import the animation. But how many of you will put all the driven constraints in the root assembly? Well, most of you don't do that. You also have drive constraints in sub-assemblies, so these are not brought over into 3ds Max. Only the root constraints. The other hand, if I select this one, immediately I do have access. Hey, do I want to have a constraint, or do I want to have the joint? So we have some options, limited options. On the other hand, what I normally do is rebuild the assembly. So I do get 100% control about how the animation, how the rigging will behave. Some other options, I'm gonna merge this with the current scene. I'm gonna import the Inventor materials. Again, appearance materials, so not physical materials. And then we have the Inventor file vertical direction. Depends on the company. Sometimes it's the Y, sometimes it can be the Z axis. Okay, so to speed this process up, what I already did, because this one takes 3 minutes and we're not gonna wait 3 minutes, so I'm just gonna open up an existing scene. So it's this particular one just to show you guys the end result. So this is, let me load the scene. So this is the assembly. So it comes in completely how it looks like. Inventor, navigation in Max. I'm utilizing my 3D mouse, so the 3D connection. I do have the space traveler. So navigation is exactly the same as where you're used to. And if I select this one, or just move over with the mouse, I do get a highlight showing me, hey, this is the assembly. So if I look in my Scene Explorer, that's how we call this one, the left side of the screen, the Scene Explorer. This is gonna show me, hey, this is the assembly. And I can expand the assembly so that I can immediately have a look, hey, what kind of parts do I have? So this is a part, this is a part, this is a part, this is a sub-assembly with a sub-assembly with a sub-assembly. So important, it completely respects my Inventor hierarchy. So it respects my sub-assemblies, my assemblies. Also, if I want to show the materials, I can sort by layer. So this is literally where I'm able to see, hey, this is a material called blue sky glass. This is the steel material. So this is what happens during import. If you want to start working with the assembly, I need to use what I said, the grouping. So every assembly will be converted into a 3ds Max group. So if I want to open the complete assembly, I'm just gonna do the open recursively. So now the assembly is completely open. So I can literally start moving the different parts. I can start animating this. And again, we will talk about animation as well. So this is an important step, how to get your Inventor data utilizing the grouping. If I'm done with the grouping, I can choose the option close. like literally close the assembly, close the grouping, and the groups are being closed. So that's how we get the Inventor data in, and again, the materials are brought over. It's not the best quality of materials, so I really strongly recommend you to start changing the materials, and we will do that. So let me go back to my PowerPoint. And again, if you have any questions, just utilize the Q&A panel. And we will share the presentation as well, so that you have some guardrails how to start working it in a proper way. Because I know many Inventor users tried to start working in Max, but after 5 minutes they gave up because there's no guidance, there's no clue, and this might help. This can be a good step. Real-time rendering. Very interesting. Real-time rendering, like what we can achieve with the high quality viewport in Inventor, introduced a couple of years ago, GPU accelerated. Max does have a huge amount of additional options to be able to set a really high quality viewport. We already see that in the video playing back. That's completely real time. And based on that viewport quality, we can create preview animations. We can create some screen captures that it looks like, hey, it's completely rendered, but it's not. So let me go back to 3ds Max and let me open up another scene. So let me go to real-time rendering. So I have a drill. This is the point where you see, hey, in the file, the system units is set to centimeter. What do you want? For now, it's totally fine. I'm just gonna adopt the file settings. So again, we have some mechanical data, navigation, utilizing the 3D mouse, and this is what you get. This is what we call a standard viewport. And what we normally do is we load in some environments. So we're gonna utilize a technique called image-based lighting or environment lighting. And the only thing what I need for that is just load from the rendering menu. In the menu bar, I need to load in an environment. And the particular environment, what I'm gonna use is what is called an environment map. The environment map. I'm just gonna click on the button labeled none, and I'm gonna load in an environment. And that's an HDRI, high dynamic range image environment, which are 360-degree environments, which are literally available to you when you install 3ds Max. Also, there are websites available like Polyheaven, where you can literally download over 700 different HDRs. So if I select this one, it's a Palermo square. Let me open this one, takes a couple of seconds to load. And now I do have a 360-degree environment. So the materials are already reflecting the environment. So that's a good step. So it's working for reflections, but still the quality is a bit low. So if I switch the viewport from standard to high quality, now also the lighting in the viewport is being affected. So now I do have some real-time environment lighting, very soft shadows, and also I do get some really nice reflections from the environment. Obviously, the object itself, it's a bit hard to identify, hey, where do I need to look at, to the background or maybe to the 3D design? So we have options. So we can completely readjust the 360-degree environment. And that's something we do in the material editor. So if I go back to the environment, I can right-click on this particular button, and I can edit this in the Slate material editor. So that's the material editor. So this will provide me access. Let me readjust this a slight bit. This is going to show me the HDR environment, and I can rotate it. So I can decide, hey, from which side is my direct lighting? being placed. I can change the amount of exposure. So if I want more or less light from the environment, I can blur the background. So if I blur the background, no one is gonna take a look at the background anymore because it's not sharp. And our brains don't like to focus on objects which are not in focus, which are not sharp. So I do have background blur, and I also have an option called use custom background. And I know what you as designers would like to see. So I want to have a complete white background, and then I want to have some shadows on the ground. So for that, I already created a basic primitive. It's called a plane. I call this object the ground plane, and I'm gonna apply a material called matte shadow. So if I just drag the matte shadow material to the ground, this is the result. And look at that. It's just, well, maybe if I don't talk, I can do this in 1 minute of my time, and I do get a high quality viewport. And why is that important? Because as it is now, I can create preview images. So I necessarily don't need to render this. So I can literally start capturing still images, or I can create a preview animation. So I do have an animated camera. So let me dive into the camera. If I play back the camera, so and again, I will talk a bit about animation. So this is the animated camera. Obviously, we can animate cameras just to explain our design, what is our intention. And I can, literally create an animation within 30 seconds by literally screen recording, and that will create my animation. So again, the viewport is high quality, and also maybe I want to introduce some nice bloom. That can be nice. So if I go to the active viewport settings, we do have, that's something from we do recognize from video games called bloom. So if I activate the bloom, we get a real nice effect like we see in video games. Maybe the bloom is a bit too strong, so I can change the strength. So just lower the value down, and maybe the radius. So I can start playing with bloom effects in real time in the viewport. So we have high quality viewports, even much better than Inventor. The other hand, it's only showing me direct light. So the render, the final render will be much better quality because it will calculate the indirect bounced light. But the other hand, keep in mind, this just took me 1 minute to visualize this particular viewport. And maybe you don't like this. Maybe you think, hey, it's too high quality. I can set this to a graphite style. Or maybe you can set this to color pencil. So now it looks bit more artist friendly. So now I literally do have the effect of a color pencil. So that's about viewports, really high quality viewports. Let me dive back to my slide deck. And this is gonna help me to set up the look and feel I want, the lighting, before I do the final rendering as well. On the other hand, 9 out of 10 times for a design render from the viewports, it's good enough. It's good enough. Okay. Materials. So obviously the next thing is materials itself. So we come from a long way. So we have different materials, but as it is today, we're working with one particular material. It's called the open PBR material, which was developed in Autodesk and Adobe, and open stands for open source. So it's compatible with every render engine. So if you render with the dedicated Arnold render engine, or you render with V-Ray, it recognizes the material. So just let me open up my other scene, open PBR, and also need to closely watch the time because there's always so much to tell when it comes down to 3ds Max. So this is some kind of a photo studio I'm normally using when I create my materials. It's a spherical object, so it gives me the best quality when it comes down to reflections, etc. I do have an environment, so the HDR, the 360-degree environment. And when I'm satisfied with the material, I store it in the material library, so I can always reuse the material. So when we need to create materials, we need to utilize the material editor. It's a node-based material editor, so this one is called the Slate material editor. And the Slate material editor, now it's occupying a lot of space on my laptop display. Normally you put this material editor on your secondary display. Okay, so in the list of general materials we have, and this is the one I recommend you. I strongly recommend you to stay with the open PBR material and the normal PBR material. So with the open PBR material, just drag it in. It creates the material. It does have a huge amount of presets, going from finishes to non-metallic materials, transparent materials, and different kind of metals. Excuse me. But it's also possible to start adjusting the material in real time. And when I really want to have a good understanding of the material, I need to start my Arnold render engine. And that's an interactive render engine, runs on CPU, GPU. Currently, it's set to CPU. And I'm gonna open up the Arnold render preview. Because this one, let me readjust my screen just a little bit. I need to make a bit more space. There we go. Because this one is interactive. So if I start the rendering immediately, this is what we will get. Okay. And for the first time, it takes a bit longer. But on the other hand, this rendered in 11 seconds. It's high quality. I have some really nice, soft-looking blurry reflections. And the cool thing is, if I start playing with some basic parameters like metalness, so if I want to create this material as a metal, I only need to set the switch to 1. And now, ta-da, it looks like a metal. And I still have some blurry reflections, and that's due to the roughness. So I do have roughness, and every material obviously does have some roughness, but now it's set to 30%. So if I set this to 0, I get a perfect looking grown material, almost, because normally I change the base color bit darker, so it behaves just a slight bit more as a grown material. So this is really easy to create a decent metal shader, metal material, set the metalness to 1, and change the roughness. So if I change this to 50%, now it does look much more as a rough material. And also I do have access to transparency, transmission, a lot of option coding if I want to have a coding layer. On the other hand, if you have some textures, and we have some really brilliant websites like textures.com, also Polyhaven, which I mentioned. So if I want to really create this to an amazing looking metal, I can also pick the other one. It's also a PBR material. It's this one, PBR material, based on metalness and roughness. Let me assign it to the upper part of the sphere, assign to the selection. And now it's really easy just by start dragging textures to the belonging inputs. And the base color or albedo, these just can be downloaded from websites. They're available. So I already did that. So where is my file? Did I? That's a good one. scenes. Yeah. Okay, open PBR. Just gonna create one due to the time, but this is what I literally downloaded. Okay, so I have an iron polished damaged, I have a steel galvanized, and I do have a fret plate material. And again, the only thing what I need to do to be able to create this material is start dragging and dropping the textures to the belonging slot. So this is the base color. And again, I just did a download from the websites, textures.com. This is the height map. This one goes into displacement. The metallic one goes in the metalness. I do have the normal, which goes to the normal. And I do have the roughness going into the roughness. Okay, so I'm just dragging and dropping the textures. And now if I restart my interactive rendering, this really starts looking like a rusty material. And again, for the first iteration of the render, it takes a bit longer. It should load because it's compiling on the background the textures, and look at that. And probably you don't like rust as a designer, but this, yeah, it looks like a real material. It does have some wear and tears. It does have the displacement. And again, this is the quality of the materials we can create with 3ds Max. So we have, yeah, there are so many textures available for creating fret plates or gold, copper, brass, carbon. You can, yeah, you name it, and it's available. So, and again, if I'm happy with this particular material, although rust, we don't like rust as an engineer, but I can save this in material library. I can literally start assigning this to the Inventor part or whatever. And this is just one simple example. Right. Animation. So let me go back to the presentation. So open PBR, that's an important one. Animation. So when it comes down to 3ds Max animation, we do have a huge amount options available. We can do manually keyframe animation just by repositioning objects and storing the position, the time in the keyframe. We can work with constraints, and you as an Inventor engineer are used to constraints. We have wire parameters, so I can create some kind of expressions. I'm gonna show you one example. Then obviously we have liquid simulation, and I've just picked one example, maple syrup, consisting of a density, viscosity, and surface tension. So if you ever wanted to do some kind of liquid simulation, we can do that. And on top of that, but that's going to be more complex, is character animation. So an example of a constraint, just gonna do, I think, one due to the time constraint. Yeah, this is a good example. I'm just gonna do two. Look at constraint. So imagine I have this set up. So in this particular example, I repositioned the pivot point, which is literally based on the fixed constraint in Inventor. And if I start moving this green box, which is a dummy object, just like helpers. So if I start moving this one, the mechanism reacts, although the piston itself, it breaks. Okay, so I need to set up the piston connection. And by the way, this movement is done by bones. Okay, so we have a bone system. Do we have time for that? Okay, very quickly, animation. Let's go to my bone tools. Just very quickly, I can create like an arm, mechanical arm, 3 bones. And then what I need to do is just add a solver. So if I add a solver, hierarchically independent, now I do have some kind of arm. Okay, so I can utilize this. So this is what I did with this particular mechanism. The thing is, the piston itself, this particular one, the upper one needs to look at the cylinder. So I can do that by utilizing the look at constraint. So this particular one is going to look at this one, but I normally add an additional dummy, which is my helper object. So I connect this particular one to this dummy. It is doing some weird offset, so I'm gonna activate keep the initial offset, and I'm gonna repeat this with the lower part, so with the cylinder. I'm gonna constrain this to the upper part of this particular dummy, keep initial offset, and if I now start moving this one, just need to remove my projects toolbar. Now the piston is working as well. So all this kind of hydraulic systems and even cables, etc., I can do that. Another example, really cool. Imagine if I have some kind of a picker or a robot arm. So the robot arm needs to pick up an object and replace it. I'm gonna do that with what is called a link constraint. So I'm gonna link this particular box to this dummy helper. Then I'm gonna position the robot arm down here, maybe frame 72. I'm gonna add a link and I'm gonna select this part, the arm hat. So immediately it starts picking up this object. Look at that. How cool is that? And now it needs to be placed on the ground. So I'm just gonna link it at this position in time to this particular dummy. Okay. So if I now go back in time and start scrubbing the timeline, it picks up the box, it places the box on the ground, and the gripper moves on. So that's what we can do with constraints. Really cool. Just a couple of examples. Another one, which is also gonna be a time saver, it's wire parameters. So where I can create some mathematical expressions. Imagine. This particular object is rotating, but the small wheels aren't. So I need to make a connection. So I need to investigate when I start rotating this particular red object, which is the z-axis. This wheel needs to start rotating on the y-axis. That's what I'm gonna set up. So I'm gonna select this one. I'm going to the what is called the wire parameters. And in the wire parameters, I'm gonna do the rotation. I'm gonna do the Z rotation, and I'm gonna connect it to the smaller wheel, which needs to be the Y rotation. Then I'm gonna make the connection. So I'm gonna connect this one. So now immediately I do have a result, but the speed of the small wheel is way too small. So what do I need to do for that? Is just multiply in the expression the radius of the red object, which is 88, divided by the radius of the small object, the small wheel. So if I update this one, now it really behaves how it should. How did I get these values? Simple. Just check the object properties. So in the object properties, this is the dimension of the red one. It's almost 88, it's not perfectly. And this one, if I go to the properties, it's 6.4 almost. So expressions, that's how we call wire parameters. Very interesting when you want to set up your mechanism or your kinematics. And we have plenty of options. And again, what you see, 3ds Max doesn't need to be very complicated or difficult. It's just you need to pick the right pieces in the program. That's the thing. So that was a bit about animation. The final rendering is done with Autodesk Arnold. And Autodesk Arnold is an advanced ray tracer. So it creates high quality rendering, reflections, indirect illumination, etc. So that's gonna be my final live example as well. So for that, I picked up one of my favorite scenes. It's called the rolling teapot. It's the rolling teapot. It does have some mechanical parts, but it also has some creative parts in this one. So this is all set up with the open PBR materials with the different presets, except the blue material. I've created this with a car paint shader provided by Arnold. So again, if I start the Arnold render view, let me start the IPR. So it's the interactive photorealistic rendering. In 1 second, I do get a result, but it looks very noisy, very blurry. So I need to do something about that. How can we get rid of the noise? Just by adding a denoiser. So in the display settings, we do have access to what we call imagers. And one of the imagers is a denoiser. And I can do a GPU denoiser. That's the AI trained, machine learning trained optics denoiser from NVIDIA. So you need to have an NVIDIA GPU installed. If you don't have a really good GPU, graphics card, you can utilize the OIDN, which is the Open Intel denoiser, which is a CPU-based denoiser. So let me select this one. So if I restart the render, it starts denoising on the first frame. It's really, really fast. And I'm always getting rid of all the noise. And look at the different materials. Maybe it's too bright. So let me add an exposure. So let me restart the render, the IPR, and now I'm able to change the exposure value. So if I think, hey, I don't like it, I'm just changing the exposure. And again, look at the quality of the lighting. Look at the quality of the materials. We still see the plane. I might need to change the dimensions of my ground plane, but I can easily do that. Let me select the plane and let me just go to modify and change the length. Maybe I need to change the angle as well. I can do that in an interactive manner. Yeah, but it looks good now. Okay, and maybe I also want to add, maybe it's a bit too dark. Let's go to minus 0.5. And maybe let me add a nice color correction. Maybe let's do a white balance. Maybe let's do some lens effects so that we can really start doing some cool stuff. Let me render just one frame, and then I'm gonna adjust the different imager. So vignetting, really nice. This is the effect of a vignette. It's a bit more dramatic, but it's more, yeah, like having an effect, like a filter. I can still change my blooming. Let's do maybe strength of 1. There we go. There's my bloom effect. Look at that. Looks really good. White balance, so I can change, you know, the Kelvin temperature color if I want. If I think, hey, my image is just too cold, it's too warm, I can change the filter color. I can change that. Maybe some color correction. Maybe just a slight bit more saturation, maybe a bit more contrast, and look at that. This is the image being rendered in a couple of seconds. So the Arnold render, this is gonna be the quality render. So the animation as well will be rendered in this quality. Back to the PowerPoint. So that about the Arnold rendering. Questions. So let us dive into the Q&A. Let's see if there are some questions being asked, so that we can hopefully answer your questions. Do I have? Yeah, I see one thing. Lee, are you there? Are you able to check the questions, please?
Absolutely. Yeah, that's cool. We've got a couple of questions yet. So Joss has asked, can you use the textures also in the open PBR material slots?
Yes, absolutely. Yeah, absolutely. Yeah, but the most simplest workflow is just drag them in the PBR material. But on the other hand, I can drag them, the textures themselves, drag them in the material editor, and then I need to manually make the connection. So I need to take the drag the output to the input of the material. So it's a bit more work. It's a couple of seconds more work. Yeah.
Cool. Good. And one more we've got from Anonymous. But
okay.
Is it possible to use Matterport scans to create HDRI 360-degree environments?
Yeah, but that's something you have to do in external software. 3ds Max, although does support point clouds, so if you have point cloud data, that can be imported or referenced. Point clouds can also be rendered, and that's really cool because there is a dedicated Arnold shader. And normally, when I load in a point cloud in Inventor or Revit or AutoCAD, if I hit render, the point cloud will disappear. In Max, when I assign the Arnold point cloud shader, it will render the point cloud, and it will also create shadows if you add lights. The other hand, yeah, there is Polyheaven again. That's the industry standard website with a huge amount of HDRs. And also what I do a lot is I create them myself based on Gen AI technology. So I'm literally prompting, create a sky with some clouds, with some nice lighting, needs to look cinematic. And then the AI will create an HDR, which I then can use in 3ds Max.
Great. Thank you. Potential there for another webinar again, JP.
Yeah. Many topics available. So
absolutely right. So that leaves us. So yes. So thank you, JP. That's been fantastic. And yeah, listen, if anyone's got any other questions, feel free to reach out afterwards. Reach out to your account managers, whichever country you're from. And oh, sorry, I've got one more question just coming right at the end. Shall I do quickly? We'll get this one in. I'm working with large process plants in Plant 3D. I would like similar webinar. All right, okay. We'll look at that one, Joachim. Yeah. So we'll come back and we'll have a look at that and see if we can come back. That was a suggestion for another webinar.
Webinar.
Please remember to fill out the survey afterwards. If you have logged off and you're watching off, the survey will get sent out as long as you've been on live. As I said at the beginning, we have got that prize for half a day online workshop with JP to talk about that Inventor to Max workflow. If anyone's interested in reaching out and discussing how they can get involved in that in a bit more detail as well, please feel free to speak to your account managers or drop me a message. My email again. I don't. JP, can you just take up my profile thing on the?
Yeah. Oh, I need to go.
So they've got my email there. Sorry, I caught you on the hop there.
Yeah, no worries.
That's all right.
Wow. They're almost there.
Gone through so much.
Almost there. There you are.
There's my details again. So yeah, feel free to reach out. And with that, I'd like to say thank you to JP once again. Thank you all for taking the time out to spend this last hour with us. And look forward to speaking to you soon. Cheers. Goodbye.
Thank you.